Hello everyone, welcome back to part 3 of this short series about 3/9 fine silver powder. And I've got all our powders all dried out and ready to be processed. And but before we get out there and take a look at these powders and do some experiments, I've got a couple of important comments left by some more experienced refiners concerning some of the processes that I used in part 1. In part 1 of the video, I stated that it is not important to rinse all of the copper off of the silver chloride before we convert the silver chloride to pure silver powder with lion sugar. And I did it anyway. I rinsed all the copper off, and I always do whenever I'm doing the lion sugar conversion method, unless I'm going to be running it through the silver cell, then it doesn't matter. But a more experienced refiner, his name is Goran. He's off of the Gold Refining Forum, and he wrote this as a comment. He said, the copper nitrate will not stay in solution when you convert the silver chloride with lye. It will be converted to copper hydroxide and small amounts of copper oxide, and they will both contaminate the silver powder in the end product. That is why it is important to wash the silver chloride free of copper before converting it with lye and sugar. So thank you for that comment, Goran Axelson. And then we've got another comment by another experienced refiner. And he pointed out that this is Aquila Refining. That's Ralph at Aquila Refining. And he pointed out that GSP, which stands for Gold Silver Pro on the Gold Refining Forum, gave this formula with respect to silver chloride conversion with lye and sugar. Aquila Refining, Ralph, he writes this. He says, Chris, GSP, gave me this formula for 1 troy ounce of silver, or 42 grams of silver chloride. It takes 20 grams of sodium hydroxide and 13 grams of sugar in 133 milliliters of water in order to do this lye and sugar conversion of the silver chloride. So thanks to Aquila Refining for that remark. And now let's get right to it. Let's go out and take a look at these powders and do a few experiments out here and see if we can get some ideas of the purity of this silver powder. Here we go. Here's our silver powder products. This is the one that we cemented on copper, and I've got it labeled number 2. Looks pretty good. Got some nice crystals going on in there. And this is the cement silver that we rendered with lye and sugar. It's got a different color to it, a little bit lighter than the silver powder that we cemented with copper. That's probably because there's going to be some copper in with our silver here. This should be high purity silver, 3/9 fine. And what we're going to do now is we're going to do some experiments to check the purity. Okay, what we're going to do is I've got 2 beakers here, labeled 1 and 2. We're going to get a little bit of the silver from each of our products in these beakers, and we're going to dissolve them in nitric acid, and we should be able to tell a little bit about the purity by the way this material looks when it gets dissolved. Go with 5 grams here. go. All right, that's 5 grams of the silver powder that we rendered with lye and sugar. Cover that up. And then we're going to put a similar amount into beaker number 2 here. This is the silver that we rendered by cementing with copper. Try to get 5 grams here. Boom, perfect. Cover that up. Now we're going to put these 2 samples up on some heat. We're going to use some nitric acid to dissolve the silver powder from each amount of silver. That's about 30 milliliters of distilled water that I'm adding to each beaker. And now we're going to add some nitric acid here. This is concentrated nitric acid. And I'm going to try to get the same amounts all the way up to the bottom of the neck of the dropper there. I'm just going to add that right into each one of these. There we go. And we're going to put it up on the heat and let this dissolve. We use low heat here. We don't want to boil these beakers over by putting too much heat all at once. All right, let me get these out of the way, and then we'll put our experiment up here on the heat and add low heat. We've got everything to go into solution in both of these beakers. So now what I'm going to do is I'm going to pull them down off the heat, and we'll let these cool down a little bit, and then we'll take a look at them. They both look pretty good as far as the color of the silver nitrate solution that we've produced. Both of these solutions look colorless and clear, which indicates we've got some high purity silver in both cases. So what we're going to do is I'm going to pull up some test tubes here, and we're going to do a little bit of a water test first. And what I'm going to do is add some of the liquid from each beaker to a separate tube here, just a little bit. And what we'll do then is just add some distilled water to these samples and see what kind of reaction, if any, we get as far as a color change or clarity of the liquid. So now I'm just going to add distilled water to both of these. Some folks have written in the comment section that when they dissolved their silver, they got a clear solution like this, but then when they added distilled water, it turned cloudy. So what we're going to do is we're going to add some distilled water now to each of these and see what happens. right, let's take a look at these samples. This is sample number 1. This is our sample from the pure silver that we rendered with lye and sugar. As you can see, there's just a touch of cloudiness in that sample, which probably is due to a little bit of silver chloride in there. That should not affect the purity, but it just goes to show you, if you was to dissolve this silver powder and add distilled water to it, there's a little bit of silver chloride in here and it will turn cloudy. The way to get around that and have that cloudiness go away, if we were going to use this for electrolyte, is we'd take our silver powder and we'd melt it into shot, and that would get rid, and then dissolve it, and that would get rid of the cloudiness for us. Okay, if you look at sample number 2 here, it looks nice and clear. It actually looks a little bit better than sample number 1. Sample number 2 looks a little better as far as the cloudiness and clarity of the liquid is. All right, for this next test, what we're going to do is, I've got 2 more tubes marked 1 and 2. Pour a little bit of our solution into number 1. From the number 1 beaker, and pour a little of our solution into number 2. From our number 2 beaker. Then I'm going to dilute each one with a little bit of water, just like we did previously. And now, what I'm going to do is I've got some 10% ammonia here, and I've got a dropper. I'm going to reach in here, and we're going to get some ammonia out of our bottle in a dropper, and then we're going to add a few drops of ammonia to each one and see what kind of reaction, if any, we get. Here we go. Here's the number 1. I got no reaction. And then number 2, this is the test to see if we got copper. If there's copper in here, it's going to turn blue. And we get no reaction from that test. So we've got all the copper removed from these two samples here. Okay, I've got the samples held up against a dark background, and you can see the cloudiness that forms after we add the water. All right, I'm going to melt up a small sample here, and we're going to dissolve a little bit of the melted silver to show you the difference between dissolving the powder that still has some chlorides in it and dissolving the shot with all the chlorides removed. Coat the dish with a little bit of borax here. Alright, I've got the tiny melt dish glazed. What we're going to do is grab a little bit of our silver here and put a chunk of it in here. And now we're going to melt this up. And then once we get it melted, by melting it, we're driving the chlorides out of this silver. And then when we dissolve the melted silver, it will be crystal clear and colorless, just like pure silver crystal. Got us a little bead of pure silver. That's how it looks. That's from the silver that we rendered with lye and sugar. You can see a reflection in it. It's so pure. And now what we're going to do is we're going to retrieve this button, and as soon as it solidifies, and we're going to dissolve it in a little bit of nitric acid, and then show you what happens when we add distilled water to it. I'm going to add a little bit of water to this clean beaker here. I'm going to put our button of silver in here. Now we're going to add a little bit of, let me get this torch out of the way. I'm going to add a little bit of nitric acid now. Nitric acid going in. It's about 5 or 6 milliliters of nitric. I'm going to cover this thing up and put it up here on the heat. Our little button has gone into solution now completely. That took about an hour to get that done. So now what we'll do is we'll take it down off the heat here, let it cool down, and then we're going to do the water addition to show that it won't turn cloudy now that the silver powder has been melted. The solution has been allowed to cool now. In fact, I let it set overnight. I went in and got some sleep. But what a difference a day makes. If you look at these two samples here, you'll see that sample number 1 on the left there, the silver chloride has actually settled out on the bottom of the test tube. And the solution is now crystal clear above it. And the silver nitrate, or the silver chloride, has settled out on bottom. So now what we're going to do is I've got, see, will this fit in here? I guess it will, yeah. All right, I've got our 2 samples back here that I added ammonia to check for copper. And they're still clear back here. These are the 2 samples I began with. Now what I have here is I've got some standard stock solution here of pure silver crystal dissolved 200 grams per liter of pure silver crystal, and I added some of that to this test tube and added water to it, and you can see it's crystal clear, no sediment. And so now what we're going to do, I got that for a comparison. I got a clean test tube here. I'm going to add some of our liquid that we dissolved from that little melted silver button. I'm going to add some of that to this now, this test tube. And we're going to add water to it and check it for any kind of cloudiness. Should stay crystal clear now that we've had it under the flame. And as you can see, it's crystal clear, just like water. No sediment, no cloudiness, just like our sample from the silver crystal here. And so the whole point of this experiment is to demonstrate that the silver powder that we have back here is high purity silver, but anytime silver is placed in contact with hydrochloric acid, silver chloride is going to form in that silver, and it's going to follow it. And I don't care what you do, the only way to get rid of it, you must melt this silver powder and then redissolve it in order to get that silver chloride or cloudiness to leave the solution. It's the only way to remedy that. All right, based on these tests and the results that I got, I must conclude that these samples, these 2 silver powders back here, are going to be high purity silver, probably very close to 3/9 fine. So now what we're going to do, we're going to disassemble our set here, get everything out of the way, and I'm going to get set up to melt some of the silver powder that we have here into some nice pure silver bars. Turning the fume hood off now. We're going to be doing some measuring, and I don't want the air flow to disturb our measurements. All right, let's start off with now this is the first time I'm setting up to melt in my fume hood like this, a big bar of silver. Hopefully the heat won't affect us too badly. What I'm going to do here is turn the scale on, and we're going to put our melt dish up here. Tear the scale to 0, change it to troy ounces, and now what we're going to do is try to get 5 troy ounces of our silver powder here into the melt dish. Let's see what happens here. This is awful light feeling. There's 1.3 ounces. 0.7. The fact that I had 2 cups of coffee this morning doesn't help. Shaking like a leaf from that. Man, when I was in the Navy, I used to drink it by the pot. Come down on the 4-8 watch in the morning from a compartment, a berthing compartment. It was so cold you could hang meat down there, down into 120-degree heat in the engine room, and a pot of well-done coffee. Tasted pretty good. There we go. All right, we're going to use 4.085 grams or 3 ounces of pure silver for this bar. All right, folks, bear with me. I'm making this up as I go because this is the first time I've used the furnace here that I'm getting ready to melt this with. This little bit of silver here can just go in my cement silver. That's going to be destined for the silver cell. I'm not going to put it back in with the pure silver powder in the in the casserole there. So let's get this out of the way. Start by turning on the fume hood. I'm going to bring my torch in here real slow from the top until we can get this metal to form a crust on it. If we put that flame directly on the silver powder, it will blow it out of the dish. Adjusting the flame down real low on the oxyacetylene torch here so that we don't get that silver to popping. Silver will absorb oxygen from the torch and then spit it back out when it starts to cool off and solidify. So what I'm going to do here is I've got the oxyacetylene, and what I'm going to do is I'm going to turn it off once I get this thing hot enough. And I'm going to grab my MAP gas torch and hold the flame of the MAP gas torch on the crucible on the molten silver as I pour it. get this nice and hot now. It'll stay molten all by itself just from the heat of the dish for a few seconds. But it will want to start to solidify as soon as you take that flame off of there. Light this torch. Just lit my other MAP gas torch. Now I'm going to secure the oxyacetylene. Get the other MAP gas torch on that molten silver, keep it molten. Pour it in our mold. Here we go. Alright. Wow. Look at that thing, man. Beautiful. That came out much better than I expected. Beautiful bar of silver from our pure silver powder that we rendered with lye and sugar. Just gorgeous. All right, I'm going to turn the fume hood off here. And what we'll do is measure up some silver from the other batch. And what I'm going to have to do here, I'm going to leave the hot bar in the mold to keep that mold hot. Now what we'll do is I got a little insulation pad here. It's a piece of ceramic wool. Zero this thing out. Change it to ounces, Troy. And now I'm going to add some of the other silver that we cemented with copper in here. It's got some cold water in a metal container. I've got that first bar that we poured in our mold still to keep it hot. A hot mold is important. Let me get this out of the way. I'll start the fume hood up. And now what we'll do is form a crust on the cement silver here so it doesn't blow out of the dish. Doing the melts inside the fume hood seem to be working out pretty good. And that way I don't have to wear a respirator to keep the fumes off of me. My shop don't get full of smoke like it used to when I did these melts. And people get to see how it's done. Let's put our other torch over here. What I'm going to have to do is grab a hold of this mold and dump that bar out. When we get ready to pour this charge of metal in this crucible. All right, let me put the oxyacetylene torch. I got to move the camera just a little bit here, get it out of my way. Keeping this flame real low. To prevent a bunch of... Well, you can overheat the silver very easily with a hot oxyacetylene torch. Oxyacetylene flame is about 6,000 degrees when it's turned up. Oh, this is nice, man, having the fumes being drawn out by the fume hood. Of course, we couldn't do this all day long. It'd probably overheat the motor. There's a lot of heat going up the stack right now. And we're just doing it for a brief period of time here, so should be okay. All right, we're getting there. We're getting the charge melted. What I'm going to do now is let's get rid of this bar out of here. Just going to flop that in the water. Now we'll adjust the torch and get that on the mold, keep it hot. Get it on the mold over here. It's important to get that mold hot before we pour the silver in. All right, I've got our charge of metal nice and hot. I'll bring up the other torch and I'll light it and have it standing by here. And then what I'll do is I'll turn off the acetylene torch, set it off to the side. If I was to just pour it with this acetylene torch, the metal would outgas in the mold and form a bunch of blisters on top of the bar and make it look real ugly. So what I do is kill the torch, grab the MAP gas, and hold that on the silver and pour it right in the middle. There we go. All right, let's get this bar in the water here. I can tell which one is which. This came from our silver that we rendered with lion sugar. Look at the crystal structure in that thing, man. That's high purity silver. Oh my goodness, that's beautiful. Man, it came out way better than I thought it would. Very nice. All right, let's look at this other bar here. This is the bar that we cemented on copper. Got a nice surface, but not as nice as the one that we rendered from our lion sugar. Okay, what a relief to see the surface of this bar. It is just amazing. You see those blue crystalline lines in there? I mean, this looks just as good high purity silver as what we get with the pure silver crystal. Now, this one isn't as pretty, but it does have some streaks in it, some of them blue streaks, indicating that we've got high purity silver. This is the silver that we cemented on copper, and this is the bar from the silver that we rendered with lion sugar. So I'm going to weigh these up now. Let's see what kind of weight we got on them. I wanted to make them 5 troy-ounce bars, but I couldn't quite get it. So let's see what we got here. Okay, the cardboard interfered with the getting this thing weighed up. As you can see, we're at 4 troy ounces on that bar. And then on the other one, we're gonna have, let's see what we got here, 4 troy ounces. So both of our bars are weighing in at 4 troy ounces. What we're going to do now is get these things stamped up and offer them for sale on my eBay store. All right, I've got a little bottle here. I've written my name on the little marker there. The bottle weighs 40.6 grams. So what we're going to do is put that on the bottle right here by my name. 40.6. That's how many grams the little bottle weighs. 40.6. Got my name on it. Okay, let's I got me a little funnel here, and I'm gonna put the funnel in the top of this container. I'm gonna crush some of this silver up. All right, here we go. I got all the powder crushed up in our casserole dish here. Load it into the funnel, or to the bottle here through the funnel. Then we'll get a weight on it and see how much of this pure silver powder we're going to get into this bottle. This is the high purity silver that produced that beautiful silver bar. All right, here we go. Get it capped off. Move over here to the scale now. Let's see what kind of weight we got on this thing. All right. The bottle weighs 40.6 grams. So the combined weight of the silver and the bottle is 93 or 97.3. So we take 97.3 minus 40.6. That gives us 56 grams, 56.7 grams of pure silver powder. And we'll list this on my eBay store. Here's our finished bar. Man, that thing just looks beautiful. We'll get this for sale on my eBay store. And I'll stamp the other one up as well, but I'm not gonna do it here on the during this video. This video is already getting to be about an hour long, so this bar didn't come out quite as good. This was from the cement silver on copper. This one is from our silver that we rendered with lion sugar. You can tell an obvious difference in the finished bars. Well, we did it. We've got 3/9 fine pure silver powder here that we rendered from the silver chloride using lion sugar, and the cement silver from the copper. It came out pretty good as well, but not as good as the pure silver powder from the lion sugar conversion, the silver chloride conversion. And what I'll do is the bar that I melted from the cement silver on copper, I'm going to mark it 990 for 20 ounces and offer that for sale as well. I don't feel comfortable putting 3/9 on it, but this one is obviously 3/9 fine. I mean, it's just beautiful. The pattern on it, the crystalline structure there on the surface of the bar, those blue streaks in there, it's just really amazing to look at it. You don't get this with any silver products that you buy from other refiners. It only shows up, it seems, with the bars that are hand poured under these strictly controlled conditions. So we're going to offer this for sale on my eBay store. I've also got about 57 grams of pure silver powder from the Lion Sugar silver chloride conversion. We'll offer that on my eBay store. And it just goes to show you the difficulty involved in getting pure metal. I mean, it's not easy. It's a long process. And if it was easy, everybody would do it. So that will conclude part 3 of the silver chloride conversion, pure silver powder, 3/9 fine. Thank you for watching.